So this one's an open response question about capacitors. They're going to tell you all about context, which is kind of going to put you off, and really you didn't need the context at all to answer this question. So be resilient. The first bit is just an explain question, and the second bit is just reading numbers from the graph and applying an exponential equation, which you should have done enough practice and you should be able to do. So this question talks to you about mobile phones having touchscreens and how that's made. The screen is charged, and when it's touched on, the charge is transferred to the user, causes a drop in the electrical potential at the point where the screen is touched. That information is not really very useful for answering this part of the question though, so I'm just going to ignore that as I go forward. The capacitor is charged by connecting it across a battery and then discharged through a resistor. In the case of the touchscreen, the user provides discharge resistance of about 900 ohms. Explain how the capacitor discharges. Now actually this question could have been answered if it was just that. Explain how a capacitor discharges. So you're going to need to be resilient, and I think where people are going to struggle with this is they're going to want to go into a bit too much detail. Actually, they were just looking for some kind of simple statements here. Essentially, capacitors are two plates which become charged. So why do they become charged? Because electrons build up on one of them. So electrons build up on the negative plate. This is actually how it becomes charged, so I don't really need to say that. But these electrons flow back around the circuit to the positive plate. And that's kind of enough for our first marking point, really. I might say, because they've mentioned it, discharge through a resistor, so through the resistor. Then they want to say that the charge decreases. And I hope you're aware that capacitors discharge exponentially. So until the charge on the capacitor is basically zero. So I think that question was probably easier than it seemed at first reading. I read that and thought, oh my word, capacitors on touch screens, this would be pretty tricky. Okay, so this is the skill that you're used to doing probably with capacitors. I've got a video on this as well that I'll link out in a card here. A capacitor is discharged through a resistance of 900 ohms. The graph shows how charge on the capacitor decreases with time. So this is the type of shape, this is the exponential shape that we were thinking of. Calculate the capacitance of the capacitor. So, well, as with all calculations, our first thing to do is to go ahead and get our equation from our equation. Okay, these are the capacitor discharge equations here. They have even done the rearranging for you. Okay, so I'm going to take that one because I'm talking about charge. That's what I've got on my axis there, and time. Okay, so I'm going to write that one out. Okay, and I want to work out the capacitance. So actually, I know I'm going to need to use this form here, where we've taken natural logs of both sides. So I might as well just do that now. Now it's a case of taking readings from my graph. Now I'm going to be careful, I'm going to convert straight away here into coulombs rather than millicoulombs. So this reading Q is 7 times 10 to the minus 3 coulombs. Sorry, rather this is Q naught here. This I'm going to take as Q here at time t, where t is 30 times 10 to the minus 3 seconds. Q is, well, let's be careful with that. That's 1, that's 1.2, that's 1.3. So is that 1. Sorry, that's 1.4, isn't it? So that's 1.3. I'm going to say that's 1.3 times 10 to the minus 3 coulombs. And now it's simply a case of plugging into that equation, and well, I could certainly rearrange first if you like, but it doesn't really matter which way around I do this.
Yeah, I think I'll just resolve that and then work backwards to that.
keep a few of the sig figs for accuracy. So RC is 30 times 10 to the minus 3 over this. So minus 30 times 10 to the minus 3 divided by that previous answer. RC is 0.0178. I don't want RC, I just want C, so I need to then divide that by 900 ohms. Gives me 1.98 times 10 to the minus 5 farads. I hope that helped. Be resilient with those capacitor discharge and exponential functions. There are loads of different ways to actually do that, okay? You can work through percentages, you can work through key kind of numbers, you can work with tangents, but the way I do it is just using those simple equations, and they're all the same type of equation, and remember how to do it that long way, which you're very unlikely to make mistakes once you've practiced a few of them.